Okay. So in the last class, we have discussed conditional probability, right? Are you able to see, ma'am? What is the definition of conditional probability? Am I audible? Okay. E and F are any two events. Okay. E and F are any two events. These two events are associated with the same sample space. Okay. E and F are any two events. These two events are associated with the same sample space of a random experiment. Then the conditional probability of an event E, we are defining the conditional probability of an event E given that F. Okay, so how will you write probability of E given F? What does it mean? Here I am going to find the conditional probability of the event E given that the event F has already occurred. So this is the condition specified here. If the event F has already occurred, then what is the conditional probability of the event E? Okay, so this is given by, already we have learned this in the previous class, the definition, and we have done some problems. So this is probability of intersection of these two events, that is the numerator. Okay, so probability of, what you will write, probability of E intersection F divided by P of F, probability of E intersection F by P of F. Okay, this is the definition provided P of F is not equal to 0. How will you find P of E intersection F? What is the formula to find P of E intersection F? You will write the events of E and F. What is E? What is F? First you will write the sample space, then you will write the events E and F, right? After that you will find E intersection F. What is the intersection of the two events E and F? Then you will find P of E intersection F. What is P of E intersection F? How to find that? What is the definition of the probability of an event A? It is n of A by n of S, right? P of, in general, suppose A is any event, then probability of an event A is defined as n of A by n of S. N of A by n of S. That is number of elementary events favorable to A. Number of events favorable to A by number of events which are favorable to S. Not a number of events, a number of events in S. Total number of elements in S. N of S means total number of elements in the sample space. N of A means number of elementary events which is favorable to A. Okay, so that is what probability of A. So probability of E intersection F is defined as N of E intersection F divided by N of S. That is number of elements in E intersection F, in the set E intersection F divided by N of S. That will give you the probability of E intersection F. Okay, then you will find what is probability of F, probability of E, everything. After finding all these things, you have to substitute the values here in the formula. This is the formula, right? This is the formula for finding conditional probability. So you will substitute it here, then you will get the answer. So first you have to write the sample space. Then you have to write the events. If the events are specified clearly in the problem, then that is not a problem. That is very clear, right? The events are not specified means then you have to specify the events clearly. You have to write the events clearly. Then you will be able to write probability of the given events, right? Probability of E, whatever, probability of F. So after writing probability of E and probability of F, then you will come to probability of E intersection F. So for this you have to find E intersection F. Then you will find probability of E intersection F using this formula that I have given here, right? P of A equal to N of A by N of S. That is number of elementary events favorable to A by number of elements in S. Number of elements in the sample space. Okay, using this formula you will find P of E intersection F, then you will substitute here, you will get the answer. So this is the procedure. Already we have done a few problems in this in the last class. And we have discussed the properties of conditional probability also. What are the properties we have studied so far? E and F are any two events of a sample space, yes. Then probability of, this is conditional probability, right? So probability of the sample space S given that the event already F has occurred is equal to 1. In probability, this property is probability of the entire space, probability of the sample space, the whole space, that is 1. But here in conditional probability, this property is getting changed as probability of S given F. This given is representing the conditional. Okay, this is the slash here we have given here, that is denotes the conditional. Okay, so probability of S given F equal to 1. This is the first property we have discussed. Then if A and B are any two events of a sample space S and F is an event of S such that probability of F not equal to 0, then addition theorem, right? Addition theorem in probability, probability of A union B, probability of A union B equal to P of A plus P of B minus P of A intersection B. Okay, if A and B are disjoint, means then intersection will be empty. In that case, probability of A intersection B is 0, right? But here in conditional probability, this property is reduced to the form P of A union B given F equal to P of A given F, P of A given F plus P of B given F, P of B given F, okay, minus P of A intersection B, A intersection B given F, right? Suppose A and B are mutually disjoint events, means that here intersection will not come, then it becomes 0. So this is the second property we have discussed. Then probability of the complement given F, probability of E complement given F is 1 minus probability of E given F. That is also we have discussed, and we have done few problems based on these simple properties, and we have come to conditional probability. In the last class we done some problems. So in today's class also we are going to do some problems in conditional probability, right? So I move on to example 1. Example 1. Example 1 is a die is thrown 3 times. A die is thrown 3 times. Events A and B are defined as below. Events A and B are defined as below. Here the die is thrown 3 times. So it's an experiment of throwing a die. It's an experiment of throwing a die. That is the random experiment. Okay. What are the events happening? There are 2 events happening. One is A and another one is B. Those events are defined. What is A? A is 4 on the third throw. A is 4 on the third throw. Okay, so when you are throwing a die, the event A is getting 4 on the third throw. Getting 4 on the third throw. What is the event B? When you are throwing a die, B is the event of getting 6. B is the event of getting 6 on the first throw and getting 5 on the second throw. Okay, getting 6 on the first and getting 5 on the second throw. What is the question? Find the probability of A given that B has already occurred. So here it is not mentioned that find the conditional probability. You have to be understand. See the question, find the probability of A given that B has already occurred. So the event B has already occurred here. The event B has already occurred here. If the event B has already occurred, then what is the probability of A? So this is nothing but the conditional probability. Some condition is specified. What is the condition? One event has already happened. What is that event? B. B is already happened. If it is already happened, then what is the impact of B on A? That is what conditional probability. What is the impact of B on A? So I have to find the conditional probability of A given B. That means I have to find P of A given B. Okay, I have to find P of A given B. So first I will write the sample space. How to write the sample space? I said sample space is the collection of all possible outcomes. Sample space is the collection of all possible outcomes of the experiment. What is the experiment we have done here? It's a throwing of a die. Throwing of a die. So if you throw a die, what are the outcomes you will get? Suppose I am throwing a single die. Then what is my sample space? What is my sample space? S equal to, I will get either 1 or 2. There are 6 numbers on the dice, no? On the faces written, there are numbers starting from 1 up to, it's coming up to 6, right? So you will get either 1 or 2 or 3 or 4 or 5 or 6. So this is these are the possibilities. This is the only possibility. Then you throw a die one time. Okay. So throwing a die once, then the sample space is collection of 1, 2, 3, 4, 5, 6. So these are the possible outcomes. Suppose I am throwing one more time. A die is thrown 2 times. Then what is the sample space? is equal to set of all. You are throwing a die 2 times. So I will get either 1 1 or 1 2 or 1 3 or 1 4 or 1 5 or 1 6, right? So here the first number is fixed. Now you fix the number as 2. So either you will get 2 1 or 2 2 or 2 3. It goes on 2 6 up to 2 6, right? Next, suppose you are getting 3 the first row and you will get 1 in the second row. Then 3 in the first row, 2 in the second row. Like that, it's coming up to 3 comma 6. Okay. Then 4 comma 1. Okay. I'm fixing the first number and varying the second number. Okay. Suppose I'm getting 4 in the first row and 1 in the second row. Then I will get 4 comma 1. 4 comma 2 means you will get 4 in the first row, 2 in the second row. It's coming up to 4 comma 6. Like that, 5 1 5 2 5 3 5 4 5 5 5 6. Then 6 1 6 2 6 3 6 4 up to 6 6. So how many possibilities are here? What are the combinations, possibilities? How many elements in S? How many number of elements in S? In the case of throwing a die 2 times, 6 power 2, 6 power 2. When you throw a die one time, then the number of elements in S is 6 power 1, right? 6 power 1 is 6 only. 6 power 1 is 6. So how many elements you count? 1, 2, 3, 4, 5, 6. Yes, it is 6, right? Now we are throwing a die 2 times. We are throwing a die 2 times. So how many number of elements in S now? I am saying that it is 6 power 2. 6 power 2. What is 6 power 2? 6 into 6. So it is 36. So there are 36 elements in S. When a die is thrown 2 times, count it 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. So if you count all the possibilities, all the events, then you will be getting 36 events totally in yes. But here a die is thrown 3 times. So I will get 6 power 3 outcomes. 6 power 3 outcomes. What is 6 power 3? 6 into 6 into 6. Okay. What is 6 into 6 into 6? It is 216. It is 216. So totally 216 outcomes in yes. There are 216 outcomes in the sample space. Yes. I cannot write all the outcomes. I cannot show. Right? How it will be? S equal to, for example, I will write few because here a die is thrown 3 times. So 1, 1, 1, right? Then 1, 1, 2, 1, 1, 3. What does it mean? In the first throw I am getting 1. In the second throw also I am getting 1. In the third throw I am getting 3. So how will I write? 1, 1, 3. Okay? 1, 1, 3. It goes up to 1, 1, 6. Then 2, 1, 1, 2, 1, 2. Like that you have to continue. So you will have 216 outcomes in yes. 216 outcomes in yes. Right? So we have written the sample space, but we cannot show all the outcomes because it's a big number. 216, it's a big number. 216 outcomes we cannot write, right? So let us write how many elements in yes. How many elements in yes? 216. This is enough for me. Next, I have to define my events A and B. A and B are clearly defined in the problem, but I should write what is A and what is B. How it will be, right? What is A? A is 4 on the third throw. I am getting 4 on the third throw. That is my A. So how will I write? A equal to set of all 4 on the third throw. So 1, 1, 4. Third throw only I am getting 4. Then 1, 2, 4. Here also I am getting 4 on third throw, etc. 1, 6, 4. Right? Then 2, 1, 4. 2, 2, 4. In every third row, third row, I am getting 4, etc. 2, 6, 4. That's what I have written here. I have given here. Then 3, 1, 4. That means in the first throw I am getting 3. In the second throw I am getting 1. In the in the third throw I am getting 4. First throw 3, second throw 1. The third throw I am getting 4. Okay. So in every third throw I am getting 4. So I have to write all the possibilities. 3, 2, 4. First throw 3, second throw 2, third throw 4. Similarly, 3, 6, 4. Then 4, 1, 4. Fix the number 4. The third throw number also fixed. It is 4 only. That is the event, right? You have to understand clearly here. Here you can fix the third value. You can fix the third value because it is clearly specified in the problem. That is what our event, right? What is A? A is getting 4 on the third throw. So this is the third throw. Third throw event I will write in the third place, right? So getting 4 on the third throw. So we can fix this number as 4. Okay, this will not be changed. So you can fix this number. Then what number I have to vary? You can vary the second place number. It goes from 1, 2, 3 up to 6. Then fix the number, first number 1. Then if this combination is over, then you can fix 2, then you can fix 3, then 4, then 5, then 6. Okay. So here we have already fixed the number 4 because that is our event. A is getting 4 on the third row. So third place we can fix as 4. But um, the first place here, when you write this combination, you are fixing the first place. It is also 1. Okay, here you are varying the second place. So 114, 124, 134, etc. 164, 214, 224, 234, etc. 264, 314, 324, etc. 364, 414, 424 up to 464, then 514, 524 up to 564, then 614, 624, etc. 664. So this is what A, right? So now we are very clear about A, how it will be, right? Next I'm going to write B. What is my B? It is also given in the problem. What is my B? B is 6 on the first throw. 6 on the first throw. So we can fix the number in the first throw. We can fix this number as 6 in the first throw. Then 5 on the second row. So this place also we can fix it. 6 comma 5. So first row 6, second row 5, then third row it can be anything. Either 1 or 652, or I will get 2, or I will get 3. So 653, or I will get 4, 654, or I will get 5, 655, or I will get 666. Now I will not get 6 because in this place 5 should come, right? That is the event. B is 5 on the second row. So the second place must be 5. So 656. 656. So this is the possibility. So we have written A now and B also. 651, 652, 653, 654, 655, 656. Right? Now find A intersection B. What is the intersection of these two events? A intersection B. What is A intersection B? Here we have 651, no? So here also you will have 651, no, because the fourth place is fixed as 4, right? So 651 will not come, 652 also will not come. This place we can check because here we are having 4 in the third row. Here also the event is A is 4, getting 4 on the third row. So these two maybe intersect. These two intersect 654. So this is the only possibility because here only I am getting 4 on the third row. Here only I am getting 4 on my third row. Because A is like that, no? A is getting 4 on the third row. So this is the only possibility, 654. So A intersection B is getting A intersection B is set containing 654. So there is only one element in A intersection B. Now tell me how many elements in A? How many elements in A that we don't want, because what we have to find the probability of A given that B has already occurred. Find the probability of A given that B has already occurred. So what we have to find? Probability of A given B. Probability of A given B. What is the formula for probability of A given B? Probability of intersection of these two events, right? So A intersection B, probability of A intersection B divided by probability of B. Probability of A intersection B by probability of B, right? So this is what I have to find. So I don't want P of A. I don't need P of A. So what I need is P of B and P of A intersection B. These two I have to calculate. P of B and P of A intersection B. So how to find that P of A and P of A intersection B? P of A formula you know, right? What is P of A? P of A is we want P of B, right? So what is the formula for P of B? P of B is N of B by N of S. This is the formula, right? N of B by N of S. That is number of elementary events favorable to the event B divided by number of elements in S. So this is the formula for P of B. So after calculating P of B and P of A intersection B, we can substitute the values here and we will get the answer P of A given B. Okay. So how many elements in B? 1, 2, 3, 4, 5, 6. There are 6 elements in B. There are 6 elements in B. So let us calculate all these things. P of B formula is N of B by N of S. N of B by N of S. So N of B means number of elements in B. Number of elements in B we have calculated is 6 by N of S. N of S means total number of elements in the set S. Total number of elements in S is 216. Right? So what is the value of P of B? 6 by 216. Okay. Then probability of A intersection B. Probability of A intersection B. So what is the formula? N of A intersection B by N of S. N of A intersection B by N of S. So number of elements in A intersection B is 1. Am I correct? There is only one element in A intersection B. So number of elements in A intersection B is 1. So 1 by what is the total number of elements in S? It is 216. So 216. Now find P of A given B. P of A given B. Therefore, P of A given B is what? This is P of A intersection B divided by P of B. What is the value of P of A intersection B? What we have calculated? 1 by 216. So this is 1 by 216 divided by 6 by 216. Okay, that is 1 by 216 into 216 by 6. So cancelling 216, you are getting 1 by 6. So P of A given B value is 1 by 6. So this is the answer. Now I move on to the next problem. Example 2. A die is thrown twice. A die is thrown twice. And the sum of numbers appearing is observed to be 6. Okay. A die is thrown twice and the sum of numbers appearing is observed. Sum of numbers appearing on the on each face of the die is observed to be 6. So sum of the numbers is 6. What is the conditional probability that the number 4 has appeared at least once? What is the conditional probability that the number 4 has appeared at least once. In the last problem, in the previous problem, it was given like that. A die is thrown 3 times, thrice. Here a die is thrown twice. In that problem itself, we have discussed how the sample space will be when a die is thrown twice, right? So in S, how many elements will be there? Totally 36 elements, right? Totally 36 elements. What is given? Sum of the numbers. Sum of the numbers appearing on the die. Sum is observed as 6. What is the conditional probability that the number 4 has appeared at least once? The number 4 has to be appear at least once. So what are the two events happening here? First we have to identify the events. What are the two events happening here? Sum of the numbers appearing is 6. Sum of the numbers appearing is 6. The other event is, what is the another event happening here? The number 4 has to be appear at least once. The number 4 has to be appear at least once. So these two events are associated with the same sample space. Yes, S equal to collection of 1 1, 1 2, 1 3, etc. 1 6, 2 1, 2 2, etc. 2 6. Then it goes on up to 6 6. So there are 36 elements in 6. So I am going to define those events. Let E be the event that number 4 appears at least once. Okay. And F be the event that the sum of the numbers appearing is 6. So what is the event has already occurred here? This event has already occurred. The sum of numbers appearing as 6. This event has already occurred. This F has already occurred. What we have to find? Conditional probability of that the number 4 has appeared at least once if the sum of the numbers appearing is 6. So I have to find that probability of E given F. Is that clear? What we have to find? Probability of E given F. Because sum of the numbers appearing is 6. This is a given, right? So this is the condition. And this event is nothing but F. And the number 4 has to appear as at least once. This event is specified as E. So we have to find probability of E given F. Next we have to write what is the event E and what is the event F. What is E? E is the event of getting number 4 at least once. Getting number 4 at least once. At least once means it can be more than 1. Okay. I told you S is 1 1, 1 2, etc. Or you can write 1 3 also. 1 3, 1 4, etc. 1 6. Similarly, 2 1, 2 4, etc. 2 6. 3 1, etc. 3 4, etc. 3 6. So like that you can write the sample space, all the possible combinations. So what is the event E? E is the event of getting 4, appearing number 4 at least once. At least once means more than once the number 4 can appear. More than once the number 4 can appear. So here in the first row I am getting 1, the second row I am getting 1. Like that 1 comma 4 means in the first row you are getting 1, in the second row you are getting 4. So 1 4 is possible. Like that 2 4 is also possible. 3 4 is possible. 4 4 is possible. 4 1. Here in the first row you are getting 4. The second row you are getting 1. Here in the first row you are getting 4. In the second row we are getting 2. Next in the first row we are getting 4. Second row we are getting 3. First row 4. Second row 4. First row 4. Second row 5. First row 4. Second row 6. So more than one time 4 is allowed. The number 4 is allowed because the condition is number 4 appears at least once. So more than one time the number 4 can appear. Okay, more than one time the number 4 can appear. So repetitions is allowed. So here in the first row we are getting 4. Here we are getting 4 in the second row. Right? So 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 1 4, 2 4, 3 4, 5 4, 6 4. That is what event E. Next, let us write the event F, the other event. What is F? Sum of the numbers appearing 6. I should get the sum as 6. Okay, I should get the sum of the two numbers from the first row and from the second row is 6. Okay. So what are the possible combinations you'll have in F? What are the combinations? Suppose I'm getting 1 in the first row. Then what number I have to get in the second row in such a way that the number is 5. The sum of the numbers is 5. Sum of the numbers is 6, right? Not 5. If I am getting 1 in the first row, then what number I have to get in the second row in order to get 6, the sum, in order to get the sum as 6, 5, right? So 1 comma 5. Then next combination, suppose I am getting 2 in the first row, then what number I have to get in the second row to make the sum of these two numbers as 6, 4. Okay, so 2 4 is 6, 2 plus 4 is 6, then 3 plus 3 is 6, 4 plus 2 is 6, 5 plus 1 is 6. So these are the possibilities. So when you write the events clearly, then you will be able to write the events. Otherwise, it's very difficult. Okay, here the sum should be 6. Sum of the two numbers from the first row and from the second row. That should be 6. So how many elements in here? Totally 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How many elements in E? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 elements in E and there are 6 elements in. Is there any intersection between these two events, E and F? Let us check. 2, 4 is here. Whether 2, 4 is in E? Yes, 2, 4 is in E. And whether 3, 3 is there in E? No. 1, 5 it is not there because what is the event E? Number 4 has to be appeared at least once. Number 4 has to be appeared at least once. So 1, 5 definitely will not be there in E, right? Because there is no 4 here, right? 2, 4, this is obviously will be in E. 3, 3 will not be in E. What about 4, 2? Yes, 4, 2 will be in E because the event is the event E is the number 4 has to appear at least once. 5, 1 definitely it will not be there in E because the event E has specified like that. What is the event E? The number 4 has to be appear at least once. Okay, so what are the possibilities in E intersection F? Only 2, 4 and 4, 2. Okay, only 2, 4 and 4, 2. So therefore, let us find P of E intersection F. What is the formula for P of E intersection F? You write the formula. P of E intersection F is equal to N of E intersection F by N of S. N of E intersection F by N of S. So what is N of E intersection F? Number of elements in the intersection is 2, right? 1, 2. So this is 2 by, what is N of S? Number of elements in S, that is 6. Already I have told, right? Because a die is thrown 2 times. So number of elements in the sample space is 36. So P of E intersection F is 2 by 36. Therefore, the required probability is P of E given F. That is the conditional probability that the number 4 has appeared at least once already are given that the sum of the numbers appearing is observed to be 6. So this is P of E given F, which is equal to, what is the formula definition? P of E intersection F, intersection of the two events E and F whole divided by P of F. So what is P of E intersection F? 2 by 36. How to find P of F? Here P of F formula. P of F is N of F by N of S. That is number of elements, elementary events favorable to the event F divided by total number of elements in S. Number of elements favorable to F is, how many elements in F? 1, 2, 3, 4, 5. So this is 5 by number of elements in S is 36. So 5 by 36. Okay, so this is 2 by 36 by 5 by 36. So 2 by 36 into, it comes to the numerator, then it becomes reciprocal. So 36 by 5. So we can cancel 36. So the answer is 2 by 5. So the conditional probability that the number 4 has appeared at least once, given that the sum of the numbers appearing is 6, is equal to 2 by 5. Is that clear? Next problem, 2 coins are tossed once. It's a coin tossing experiment. The last two problems are throwing die. Random experiment is throwing a die. Throwing a die 2 times, throwing a die 3 times. So here the random experiment is coin tossing experiment. Okay. So 2 coins are tossed once. So we are tossing 2 coins one time. We are tossing 2 coins simultaneously. Once means what? Simultaneously. At a time. We are tossing 2 coins. Where E is the event of getting tail. Where E is the event of getting tail on one coin. And F is the event of obtaining head one coin. So tail on one coin is E and head on one coin is F. This is the first subdivision. There are two subdivisions given in this problem. Second subdivision is no tail appears. Second subdivision is no tail appears. That is what E. there are two events happening here, like in the first subdivision. So the first event is no tail, is no tail. And what is F? F is the event of obtaining no heads, obtaining no heads. So let us solve one by one. The first subdivision we first do. Two coins are tossed once. So in a coin tossing experiment, suppose you are tossing a coin only one time means, then what are the possibilities you will have? Either you will get head or you will get tail, right? So when you toss a coin one time, then the sample space is S equal to set of all H comma T. Okay. There are only two possibilities. Suppose a coin is tossing two times, but not like that. Here, two coins are tossed once. Two coins are tossed once. Here we are not tossed a coin two times. Two coins are tossed once. Okay, there are two coins tossed one time. So either the sample space will be either I will be head in the first coin, at the same time head in the second coin. So either I will get head in the first coin and head in the second coin. This is one possibility. Or I will get head in the first coin, tail in the second coin. Then tail in the first coin, head in the second coin. Or I will get tail in both the coins. So these are the possibilities. Either I will get head in both the coins or head in first, tail in the second coin, then tail in the first, head in the second coin, or I will get tail in both the coins. So these are the possibilities. So for the first case, you are having two outcomes, no? So 2 power 1. For the second case, 2 square. So how many numbers in S? There are 4 elements. There are 4 elements in S. Okay. So next we have to write the events E and F, that is the given events, right? So we have to write it clearly. So here E is tail appears on one coin. E is tail appears on one coin, and F is one coin shows head. One coin shows head. So how E will be? E is appearing tail on one coin. So E is we are getting tail only, not head. E is in the event E we are speaking about tail, not about head, right? So either I will get tail in the first coin or head in the I will get tail in the first coin, head in the second coin, or I will get head first coin in the second coin, tail. So tail appears on one coin. So in the first case, tail appears in the first coin, or tail appears in the second coin. That means on one coin, only one coin, not in both the coins. You should not take this outcome, no? We have to be very clear. We should not consider TT. That's what here mentioned clearly. E is tail appears on one coin only, not both the coins. Not both the coins. Here you are getting tail on both the coins. Here you are getting head on both the coins. But here only you are getting tail in only one coin. Here in this outcome I am getting tail in the second coin. In this outcome I am getting tail in the first coin. Whereas in this outcome I am getting tail in both the coins. Here I am getting head in both the coins. I should not consider this to write the event E. Is that clear? So I should consider HT and TH alone. So how many elements in E? There are 2 elements. Okay, similarly, how will you write F? F is one coin shows head. Like that, how you have defined E, no? You have to define F. One coin shows head. Only one coin. So either I will get head in the first coin or I will get head in the second coin. So if you get head in the first coin, then the next one will be tail. Okay. Suppose you are getting head in the second coin, then in the first coin you will get tail. Okay. You are getting head in the first coin means then you will get tail in the second coin. Or if you are getting head in the second coin means then you will get tail in the first coin. So what is F, H, T, T, H? H, T, T, H. So number of elements in E and number of elements in F are the same. Next, is there any intersection between E and F? Yes, there is a intersection between E and F. What is the intersection? E intersection F equal to HT comma TH. Because F is HT comma TH, E is also HT comma TH, so the intersection is also the same only, HT comma TH. So how many elements in E intersection F? 2. Now find P of F. What is P of F? N of F by N of S. N of F by N of S. N of F is number of elements in F is 2. Number of elements in the sample space S is 4. There are 4 elements now. 1, 2, 3, 4. So what you are getting is 1 by 2. Next, P of E intersection F. Because what we have to find here? P of E intersection F. So P of E intersection F is here the question is actually incomplete. Here you have to find P of E intersection F. Sorry, P of not E intersection F. P of E given F. P of E given F. That is the question. Okay. Find P of E given F. So P of E given F is intersection of these two events by P of F. So P of E intersection F, let us find P of E intersection F equal to N of E intersection F by N of S. What is N of E intersection F? N of E intersection F is number of elements in E intersection F is 2. Okay, there are 2 elements. So this is 2 by number of elements in S is 4. So 1 by 2. P intersection F, P of E intersection F is 1 by 2. P of F is also 1 by 2, right? Let us find P of E intersection F. So P of E intersection F is, sorry, P of E given F. P of E given F is P of E intersection F by P of F. So this is 1 by 2 by 1 by 2. You can cancel 1 by 2, then you are getting 1. So the required value of P of E intersection F is stop with this. We will see the remaining in the next class.